The code for this demo is available in the GitHub repository. Inside this repo, you'll find a production-ready model context protocol server designed for Kubernetes observability and debugging. Here's what it provides: an MCP server with real-time data access, built-in debugging tools, and production-ready deployment support. Before you start, make sure you have the prerequisites: a Kubernetes cluster, local or remote, kubectl configured and working, Python 3.11 or higher, and the pip package manager. Let's walk through the quick setup. Clone the repository, install the dependencies, verify the setup. Once it's running, the MCP server provides access to key Kubernetes resources, including all pods with their status and details, services with endpoint and connectivity information, node health and capacity insights, recent cluster events for troubleshooting, deployment status, including replicas. You can see it in action through usage examples, such as a basic demo, a debugging demo, and running the MCP server in your own environment. Now that we have the setup ready, let's go over the flow diagram to understand how everything works together. Our process begins with the user, who is on the left-hand side of the diagram. The user interacts with the system via the command line interface, or CLI. From there, the command is sent to the MCP server. The MCP server is the central component that processes all requests and fetches information from the Kubernetes cluster. Next, the MCP server uses the Kubernetes API to connect with our cluster resources. This is how it gets real-time data on pods, services, and nodes. The server then processes this data and sends the output back to the user, providing them with the necessary information for debugging. This entire process is designed to be a quick, real-time feedback loop, allowing for efficient observation and troubleshooting. Let's start by confirming our prerequisites. To follow along, we'll need kubectl for Kubernetes access, Python 3.11 or higher, and a running Kubernetes cluster. Here, we can see kubectl version 1.32.2 is installed, and our Docker desktop cluster is up and accessible. The project includes a quick start script that handles setup automatically. Let's run it now to install dependencies and verify the environment. Run /quick_start. Done. The script installed the MCP and Kubernetes Python packages and verified our cluster by spinning up a test Nginx pod successfully. Now, let's run the basic demo script to see the MCP server in action. Run Python 3.11 demo_script.py. Great. The demo highlights MCP's observability features. It retrieved live data from our cluster: 12 pods, 3 services, 1 node, and 2 deployments. It also flagged problematic pods like bad pod and failing pod stuck in crash loopbackoff, while confirming healthy system pods like core DNS and the API server. With MCP, you can access 5 key Kubernetes resources, pods, services, nodes, events, and deployments through one standardized interface. Let's check out advanced debugging with the debugging demo. Run Python 3.11 debug_demo.py. This workflow demonstrates how MCP supports real debugging tasks, analyzing service connectivity, checking endpoints, and spotting resource usage issues. It even suggests installing the metrics server for deeper monitoring. The MCP server provides 4 built-in debugging tools: cluster health checks, pod status analysis, service connectivity verification, and log retrieval. Under the hood, the MCP server runs as a STIO service, communicating over standard input and output. This design makes it easy to integrate with MCP clients like Claude Desktop Custom Apps or CI/CD pipelines. It abstracts the Kubernetes API into a consistent, real-time interface, so you get the insights without the complexity. Integration is where MCP shines. You can connect it with Claude Desktop for AI-powered debugging, build monitoring dashboards, or plug it directly into CI/CD workflows for automated health checks. The MCP protocol guarantees consistent and reliable access to Kubernetes data across any client. In just a few minutes, we've set up a full Kubernetes observability solution powered by the Model Context Protocol. With the MCP server, you can debug issues, monitor cluster health, and seamlessly integrate Kubernetes insights into your workflows. Thanks for watching. The Kubernetes MCP server is ready to transform the way you interact with your clusters.